that would be countable. And as we will see, that implies that we have another part now of the Nyquist path. And before we saw that the big infinite semicircle mapped into a zero radius semicircle. Any wild guesses where the zero radius semicircle will map? Infinity radius mapped into zero radius semicircle. Zero radius semicircle will map where? See? Yeah. Okay, so as we will say, we have another section of the Nyquist path, and that will map to an infinite radius semicircle.
Are we taking a break?
All right, but now let's exclude integral action, and let's do some examples of how we calculate those encirclements. So I will do 3 specific examples. Not this way. I need to finish this before. So I will do, and we're putting an x with a location of -1, 0. So I will do, let's say this is then C plus, here is the C minus. So let's say I have this Nyquist this Nyquist plot, and in case 1, let's say x is here. In case 2 minus, okay, actually let me do 3 times. So in case 1, let's say -1, 0 is here. In case 2, example 2 will do the same thing, but let's say my circle is bigger, so the -1, 0 is, so here is my x, and this goes.
Oh.
Notice I'm drawing arrows. Arrows are important. So this is case 2. So that x is the location of -1, 0. Okay? And case 3, let's say the circle is even bigger. Let's say here is my x, and the circle is going to. Okay, so let's calculate what n is in each one of these cases. And let me put something else here. What does it mean to encircle a point? Number of clockwise encirclements is number of times angle decreased by 360 degrees when we return to the starting point. And let me explain that before I do the example. I shall put that first. But here is an obvious case where I have one encirclement. So let's say I have this situation. So take any starting point, for example this one. You center it at -1, 0, because I'm talking about circumference of -1, 0. So center it at -1, 0, and move around. 0 degrees, minus 90, minus 180, minus 270, and when I go back to my starting point, my angle goes down 360 degrees. Here's another example. Let's say I have this situation. Okay, so let's start from this symmetric. Hope I did it. It should be symmetric. Is this symmetric?
No.
Roughly.
Kind of.
Well,
This should have been more outside.
Two.
No. Let me draw that. Always have a hard time drawing those things. Well, let's see. Something like that. Let's see. Symmetric.
Huh? Yeah.
That's close.
Yeah.
So,
Go there.
okay. So let's say minus 1, 0 is here. Start from any point. Let's say if I start from here, 0 degrees. Right here, minus 90. Right here, minus 180. Continue inside, minus 270. Minus 360. Minus 450. Minus 540. Minus 630. And I'm back here, minus 720. I dropped 360 twice. Pillars.
Yeah, but the first time that you did 360, you didn't come back to the place where you start.
Yes, I did.
No, you start over there.
Yeah, this one?
No, the other one.
Yeah. I start here.
And when you come back 360 the first time,
Yeah, let's do it again. I start from this point, 0. I'm down here. Minus 90. I'm continuing here. Minus 180. Minus 270. Minus 360, I'm now here.
stop right there.
Yeah?
See, you're not coming back to the point where you start.
Yeah.
He's
When
got
I
one more
come
row.
back, I'll have dropped minus 720. I'm minus 360 here. That's not the point I started, so I'm not done. I need to return to my starting point.
The origin is the X.
So it's only one, right?
No, I'm not back here. I need to count how many times I dropped 360 when I return to my starting point. So right here I am minus 360, continue. Minus 450, continue. Minus 540. Minus 630. And when I finally get back to my starting point, minus 720. So this one has minus 360. So that means n was 1. This one has minus 720. N equals 2.
Yeah. Can we just count the circles? That's so much easier.
Okay. So, what's this? Can we just count the circles? So much easier. So what's your guess for this one?
720 plus 360.
So how many, what do you think N is for this one?
360.
Okay, so I want one answer.
Yeah, 360 times 3. I don't know.
It goes around twice.
So, Josh says N would be 2. What would we say N is for this one?
I said 3.
3. Okay. So let's say one of Josh is right, but I'll start with the easiest one. Okay? So let's do those 3 examples. And let's assume that these are plots where GU has all poles with negative real parts. So N must be 0 to have closed loop stability. Right? So let's take those 3 cases. First case. Pick any point to start from. Maybe I'll start from here.
Oh no, it's 6. I think. Yeah. 5.
Okay? Remember, the center has to be
Yeah.
the x, not the origin. Minus 1, 0. So here is 0. When I'm going clockwise, the angle drops. If I reverse direction, the angle increases. Careful about that. So, 0, minus 20, minus 30, continue, maybe minus 45 here. Up to here I've been going clockwise. But once I reach this point, how am I rotating now? What's this direction of rotation? Counterclockwise. Once I reach the tangency point, the direction of rotation from minus 1, 0 reverses. So the minus 45 here now starts increasing. Minus 30, minus 20. When I come back here, it's back 0. Plus 20, plus 30. I reach another tangency point. Once I reach this tangency point, which way now I'm rotating again? Clockwise. Now I start dropping again. So the plus 30 becomes plus 20, plus 10. I'm here, 0. I'm continuing going clockwise, minus 10, minus 20. I reach another tangency point. So now I'm going to go back counterclockwise. So minus 20, minus 10, I'm here on 0. Plus 10, plus 20. Another tangency point. I'm going back to clockwise. So the plus 20 becomes plus 10, 0, minus 10, minus 30. Another tangency point. Counterclockwise, increasing. Minus 20, 0, plus 20, plus 45, whatever it is, or plus 60. Another tangency point. I'm going down again. Plus 45, plus 30, come back to my original point, 0. So the net result is 0, and so in this case, n is 0. Kind of obvious because the x is outside. Clearly it's not a circle. Johnson.
Yeah, I would have said 0, but I have no clue how you just did that whole process. I would have just said 0 because the x isn't inside.
Yeah, but remember, I'm going to do the whole process because, as you'll see, neither you nor Juan answered correctly example 3.
No, I have no idea how to.
Okay, let's do example 2. Example 2 looks like a 2, right? That's probably not. Let's do it. Example 2. We can now start from here. Remember, the center is the x. 0. Going clockwise, so the angle is dropping. Minus 30, let's say minus 45, minus 90 here. Continuing minus 180 when I hit here. Minus 270. I come here minus 360. Minus 390, minus 400, I reach the tangency point. At the tangency point, I suddenly move now counterclockwise. So the minus 400 now starts increasing. Minus 380, minus 360, minus 340, minus 320. I reach another tangency point. Now I go back to clockwise, so it goes down again. Minus 340, minus 360 when I hit here.
Yeah, 2.
Minus 450 here. Minus 540 here, minus 630 here, and finally I'm back here, minus 720.
Oh, 2?
So minus 720, so 2 is correct. And it goes drop, minus 720, so n equals.
That one is 3.
All right, now let's look at the third one. So try to understand this. Let's start again. Here, 0, minus 90, going clockwise, drops. At this point, minus 180, continue going clockwise, minus 210. Let's say minus 250. But at this point, I have a tangency point.
So 2.
Every time I reach a tangent point, the direction reverses. Which way am I going now? Counterclockwise. So the minus 210 starts increasing, becoming less negative. Minus 200, minus 180, minus 90, 0 here, plus 90, but you're going counterclockwise, plus 180 here, plus 210 here. Another tangent point. Now, how do I go? Back to clockwise. last 210, last 200, last 180, 90. When I come back, 0.
0. Damn
So
it.
n is 0. Not 3, not 2, 0. Adam.
So, could you just look at the x where it's at, and then count the concentric circles around it, and over clockwise?
Essentially, yes, and I will explain that in a minute.
Okay.
Now, you understand why this is 0 and circle. I told you that you may need to bring a string for your exam. But then I said, well, maybe not a string, but make sure that you bring a clear ruler, straight edge ruler. So this is the principle for the number for circle. Luckily for your unhappy faces, you won't have to do that. There's a much easier way to figure out the correct n.
Thank God.
Draw any straight line from x going to infinity and beyond. So here I can draw, for example, this straight line, or this straight line.
Okay.
And it's going to be equal to number of, that's why I have the cut in the clock there, of clockwise cuts minus number of counterclockwise. So, no matter which line I draw, I will get the same answer if I've done it correct. Let's follow, that's why you may want actually to bring a string, to figure out if the cut is clockwise or counterclockwise. Obviously, if I draw this line, how many clockwise cuts do I have? None. 0. So clearly 0 from this line. What if I draw this line? Draw the arrows every time. The arrow goes like that. So here I have 1, 2, 3, 4 cuts. Let's see how many of them are clockwise, how many of them are counterclockwise. To figure out if a cut is clockwise or counterclockwise, you may want to have a string, set it on the x, put it where the curve is, and then move in the direction of the arrow. And see how it makes the chord rotate. So the first cut, it moves me up. If I move up, which way am I?
Counter.
Counterclockwise, guys. This is clockwise. This is counterclockwise. Okay? Clocks go this way. So this would make me move this direction, counterclockwise. So this would be a CC cut. The next cut. Which way does it make me rotate?
Clockwise.
Again, the arrow is this way. So which way does it push the chord? Up or down?
CC.
Up. What's that? CC. Exactly. So that's the second counterclockwise. Set it on X. Put the end of the chord where the cut is, and then move in the direction of the arrow. It pushes me up. Up is which direction? Counterclockwise. This direction. Okay? Counterclockwise. I'm following the direction of the arrow. Next up, it's this one here. So this was counterclockwise, this was counterclockwise. Now the arrow sort of pushes me in which direction? Down. The arrow pushes me down, right? That's the way the arrow pushes me. Which direction is that? Clockwise. Here, which way does the arrow push me? Which direction is that? So, if I follow that line, n is 2 minus 2, and get 0. Obviously, it's not the most intelligent thing to draw this line instead of this line. Okay? Maybe in the homework you want to have fun drawing the funky line, but in an exam I would recommend to draw the line with minimum number of cuts.